Okay, on problem number 11, the directions say find an equation for the tangent line. The graph of f of x equals x to the fourth minus 3x squared plus 2 at the point where x equals 1. So the very first thing that we need to do is we need to go ahead and remind ourselves that the equation of the tangent line, we can either use the equation y equals mx plus b, or we can use y minus y sub 1 equals m times x minus x sub 1. But before we do that, we need to make sure that we have our other point. So we need to go ahead and find the y coordinate that correlates to this x coordinate of 1. So to do that, you're just going to go ahead and use substitution. So when we're using substitution, we're going to go ahead and put the 1 in for our x into our equation to find that y coordinate. So when we do that, we've got 1 to the fourth minus 3 times 1 squared plus 2. Now simplifying that down, I've got 1 to the fourth is going to equal 1. Negative 3 times 1 squared is going to be negative 3. And then I've got plus 2. So when I take 1 minus 3, I'm going to get negative 2. And negative 2 plus 2 is going to be equal to 0. So the y coordinate that goes along with my x coordinate for my equation is going to be y equals 0. Now that I've done that, I can go ahead and find the slope equation. So remember, the slope equation is the first derivative. So here's my point 1 and 0 that I've got. And now I'm going to go ahead and find the derivative of x to the fourth minus 3x squared plus 2. So I'm going to find that derivative. So in order to find the derivative of x to the fourth, you can take that 4 multiplied out front and then subtract 1 from the power. That's going to give you 4x cubed. And now I've got negative 3x squared. So again, I'm going to take that 2 times that negative 3, which is going to be negative 6, and subtract 1 from my power, so it's going to be negative 6x. And then the derivative, of course, of positive 2 is just going to be 0, so it's not even going to be there. So now you've got your first derivative, which is also known as your slope equation. And so your slope equation that we've got right here is going to be 4x cubed minus 6x. So since I'm looking at the point 1 and 0, find that slope. Remember, this is the xy pair. And so now I'm going to go ahead and substitute in 1 for my x value. And I'm going to go ahead and find that slope. So when I substitute in 1 for the x value, that 1 cubed is 1. And 1 times 4 is going to be 4. And then I got minus 6 times 1, so that's going to be minus 6. And 4 minus 6 is going to be negative 2. So here's my slope now that I can now use for my equation. And I'm going to go ahead and substitute that in. And when I substitute that in, so I'm going to go ahead and use the equation y minus y sub 1 all equals m times x minus x sub 1. So I got y minus y sub 1 all equals m times x minus x sub 1. I found my slope. I found the point that goes with my x value. Now it's just a matter of substitution. So inside of my y sub 1 right here, I'm going to put in y sub 1 of 0. So I've got y minus 0. I found my slope is going to be at negative 2. So substituting in that slope of negative 2. And then for my x value, I've got 1. So I substitute that in right there. So I got y minus 0 all equals 2, negative 2 times x minus 1. And I just have to simplify that down, solving it for y. And when I solve it for y, well, y minus 0 is just going to be y. I'm going to distribute this negative 2 on through, so I'm going to get negative 2x, and then that's going to be plus 2. So my tangent line equation at that particular point is going to be y equals negative 2x plus 2. Looking at this next problem right here on number 12. Problem number 12 says find all points on the graph of f of x equals x to the fourth minus 2x squared plus 3, out of which there is a horizontal tangent line with a slope of 0. So first thing I need to do is I need to go ahead and find my slope equation. So here's my equation, x to the fourth minus 2x squared plus 3. I'm going to go ahead and find the derivative of x to the fourth. So then we're going to multiply that 4 out front, and you're going to get 4. And then you're going to subtract 1 from the power, so that's going to give you 4x cubed. And I'm going to go ahead and find the derivative of negative 2x squared. So the derivative of negative 2x squared, remember, multiply that 2 on through. So 2 times negative 2 is going to be negative 4x. And subtract 1 from that power. So now you got 4x cubed minus 4x is going to be your your slope equation. Now it said I had a slope of 0. And I'm going to go ahead and substitute in 0 into my equation. I'm going to go ahead and solve it by factoring. So I got 0, all equals 4x cubed minus 4x. I'm going to go ahead and factor out a common 4x in both terms. So notice this term right here has a 4x in it, and this term right here has a 4x in it. So I'm going to go ahead and put that out front. This is opposite of the distributive property. Now when I divide 4x cubed divided by 4x, that's going to give me x squared. And when I divide 4x by, or negative 4x by 4x, I'm going to get negative 1. Now that I've done that, I'm going to go ahead and factor the x squared minus 1. So x squared minus 1 is going to factor down to x plus 1, x minus 1. So factored completely, I've got 4x times x plus 1 times x minus 1. I'm going to go ahead and set each one of these equal to 0 and solve it. So notice when I take the 4x and set equal to 0, I divide both sides by 4 and I get x equals 0. When I take the x plus 1, set equal to 0, I'm going to add negative 1 to both sides, so I get x equals negative 1. And when I take x minus 1, set equal to 0, I'm going to get x equals 1. So those are my x values. I've got 0, I've got negative 1, and I've got positive 1 as my x values for my points. So now I've got to find the y values of those. So notice, to find the y values, you're just going to take these x values and substitute it back into the original equation. So I just take that 0, I come up to my original equation, and I'm going to go ahead and substitute in 0 into my original equation, find the x or the y value that correlates to it. So if x equals 0, I got 0 to the 4th minus 2 times 0 squared plus 3, so that comes out to be 3. So that point correlating to 0 would be 0 and 3. And I'm going to go ahead and substitute in a negative 1. So back up to my original equation and substitute in negative 1 to find the y value that correlates to it. So when I substitute in negative 1, I'm going to get negative 1 to the 4th minus 2 times negative 1 squared plus 3. So negative 1 to the 4th is going to be 1. Negative 1 squared is 1, and 1 times negative 2 is going to be minus 2 plus 3. So 1 minus 2 is going to be negative 1, and negative 1 plus 3 is going to be 2. So that point, that's going to be negative 1 and 2 at the very end. Now if you go ahead and substitute in a positive 1 to find that other point, we'll go ahead and find that other point by substituting in a positive 1. So when I substitute in a positive 1, I'm going to get 1 to the 4th minus 2 times 1 squared plus 3. So 1 to the 4th is 1, 1 squared is 1, and 1 times negative 2 is going to be minus 2 plus 3. When I take 1 minus 2, I get negative 1, and negative 1 plus 3 is going to equal positive 2. So that other point is going to be 1 and 2. So notice, that's going to be my answer, is those 3 points right there. So those 3 points at the very end is going to be 0 and 3, negative 1 and 2, and 1 and 2. On number 13, it gives us this equation. It says find the instantaneous rate of change with W with respect to Z, or W all equals 3Z plus 4Z squared. So remember that your instantaneous rate of change is just your first derivative. So I'm going to rewrite this algebraic equation right here of 3Z. I'm going to rewrite that to 3Z to the negative 1. I'm going to leave my 4Z squared as 4Z squared because it's ready to be derived. So now to find the derivative of this, so since I'm doing it with respect to Z, you're going to notice the Z is already in my equation. So all I have to do is just go ahead and take the derivative. I'm going to take negative 1 times 3 and get negative 3. And I'm going to subtract 1 from that and I get negative 2. So that entire derivative is going to be negative 3z to the negative 2. Now I'm going to go ahead and take the derivative of 4z squared. So I'm going to take 2 times 4, which is 8, subtract 1 from it. So that's going to be plus 8z. I go ahead and move that z to the negative 2 back down to my denominator. So notice when I do that, it changes it to positive. So I get negative 3z squared plus 8z. And that's going to be the derivative, or the instantaneous rate of change, because that is the first derivative. So your answer is going to be negative 3z squared plus 8z. On number 14, it says, suppose the position equation for a moving object is given by s of t equals 2t squared plus 3t plus 6, where s is measured in meters and t is measured in seconds. Find the velocity of the object when t equals 3. So just a reminder, your velocity is your first derivative. So all I have to do is just find the first derivative and then substitute in t equals 3. So here's my position function, s of t equals 2t squared plus 3t plus 6. I'm going to go and find the derivative of that position function. So I take 2 times 2, which is going to be 4. And then I'm going to subtract 1, so that's going to be 4t to the first. And then I've got plus 3t, so the derivative of 3t is going to be plus 3. And the derivative of 6 is going to be 0. So my velocity equation, or in other words, the first derivative, is going to be equal to 4t plus 3. Now to go ahead and find the velocity at 3, I'm just going to take 3, substitute it in for t. So I got 4 times 3, which is going to be 12, plus 3. And 12 plus 3 is going to be 15 meters per second. So our velocity at time equals 3 is equal to 15 meters per second. Now this last problem right here on number 15. Number 15 says the following. It says the formula for the volume of a cylindrical tank is V equals 1/3 pi r squared, where r is the radius of the tank. If water is flowing in at the rate of 15 cubic feet per minute, find the rate at which the radius is changed when the radius is 3 feet. So remember, we're going to have to use our implicit differentiation because we're differentiating with respect to time. So notice I'm going to take my formula right here, V equals 1/3 pi r squared. I'm going to go ahead and derive it. So remember, the derivative of V is just going to be 1. But then since I'm deriving with respect to time, I've got to write dv dt. I'm going to go ahead and take 2 times 1/3 pi, and that's going to give me 2/3 pi, and then I'm going to subtract 1 from that. That gives me 2/3 pi r. And then since I just derived the radius with respect to time, I have to write dr dt next to it. So the equation that I'm working with is this equation right here. The derivative dv dt equals 2/3 pi r dr dt. Now that I've done that, it's just actually a matter of using substitution. So reading the original problem, it says that if water is flowing in at the rate of 15 cubic feet per minute, well, that would be dv dt, because that is describing how the volume is changing. This says find the rate at which the radius is changing. So I'm going to find dr dt. I'm finding the difference of the radius with respect to time, and it says when the radius is equal to 3. So now it's just a matter of substitution. So in place of dv dt, I'm going to put 15, and then I still have my 2/3 pi, and it says when the radius is 3, so I'm going to substitute in my 3, and then I'm going to solve this for dr dt. So solving for dr dt, I've got 15 equals 2/3 pi times 3. And notice these 3's are going to cancel right here. So since the 3's cancel, you're going to be left with 2 pi. And now I'm going to divide both sides by 2 pi. So dividing both sides by 2 pi, I'm going to get 15 all over 2 pi equals dr dt. And I'm going to just go ahead and leave that in terms of pi, and that would be my answer.